In this video, we're going to go through an example using the exponential distribution probability formula. And we're also going to examine or use the memoryless property of the exponential distribution. Okay, so here it goes. Problem setup. Let us examine the times it takes call center specialists to resolve incoming calls. The times follow an exponential distribution. It takes, on average, 2.5 minutes to resolve each call. And after 5 minutes of being on a call, the specialist has a warning pop up on their screen urging them to wrap up the phone call. Question: what is the probability, after receiving the warning, that it takes at least another 5 minutes to wrap up the call? Okay, so some things to note here. What we're going to do is we're going to use time units of 1 minute at a time, or of minutes, if you will. So you need to pick a time frame. Often there's an easiest one to pick. Because everything is in minutes here, it makes sense to use minutes instead of, for example, seconds or hours. That would just make the whole problem complicated. So if there's an easy kind of time scale to use, then use it. Next, we need to figure out what lambda is. This is our average. Sorry about that. And this is our average number per time unit. Be careful with this one, because often when we're dealing with exponential distribution questions, we're given the average time per event, but what we really want is the average number per time unit. So it takes 2.5 minutes to resolve each call. So really that means there's one call resolved per 2.5 minutes. So what we really want is the number of calls per minute. So we take the 1 over the 2.5, like that. And that gives us 0.4. Or if you will, we can say there are 0.4 calls per minute that are resolved on average. So that's now our lambda. Okay. And next, let's figure out our X range. So this is where we need to think a little bit about this problem. So what's happened is the following. So the person has been on, or the call center specialist has been on the phone with one customer for an entire 5 minutes so far. They're on this call. And then right here, they receive that warning at the 5 minute mark. Now, the question is actually asking, after receiving that warning, what are the odds that the call lasts at least another 5 minutes? So it keeps going 10 minutes or more, perhaps. So something we have to be really careful of with exponential distributions. And by the way, call center calls are fairly often modeled with this exponential distribution. And you can imagine it, you have these calls that can just go on for an incredibly long time. And it doesn't matter that these first 5 minutes happened. It could keep going for another 5. We don't know. So basically, it doesn't matter that the specialist has been on the phone with this person for 5 minutes. They're just as likely to be on with them for at least another 5 minutes, if that makes sense. So we reset the clock at this 5 minute mark. Basically, when we receive that warning, we're starting from there, And after we received it, what are the odds that it takes at least another 5 minutes is our question that we want to solve. So really, we want the probability for this next time after this warning. What are the odds that this part of the call lasts at least another 5 minutes? And so we ignore the first 5 minutes. Again, this memoryless part means that we just ignore the fact that 5 minutes has already passed. It does not affect our probability. So really, we want the probability that x is greater than or equal to 5. And we plug that into our formula. So probability that x is greater than or equal to some number is e to the minus lambda times x. So in our case, that becomes e to the minus 0.4, lambda was 0.4, times that by 5, and minus 0.4 times 5 gives us minus 2. Now let's look at how we answer this in the calculator. So do the exponential key, and then 2 negative. Sorry, forgive me. Every calculator is slightly different. For this one, we're going to use the e first. So it depends on your calculator as to what you need to put first. We're going to use the e. So this is for the Windows computer calculator. I've put it in scientific mode. Punch in the e first, and then use the power key, and then 2, and then plus minus to make it negative, and then hit equal. Good. So 0.1353 is the answer. Okay, or if you will, there's a 13.53% chance that the call will last at least another 5 minutes. Okay, thanks for watching. That concludes this video.